Okay, so what if we're blending different types of operations together? Right? What if we want to do a large number of operations in the same equation? How do we figure out in what order to reverse those operations? And how do we figure out what the actual way to reverse the operations is? And so what you can see in front of you is an equation that I've color-coded to represent a bunch of different operations that are in play. You can see a -4, a set of absolute value bars, something being multiplied by 3, and x to the third power. And so all of those operations have to be reversed before we can know what the actual answer is to this equation. Alright, so if I want to do that, I'm going to start, and this is where experience really comes into play. I need to start as far away from the variable as possible. As far away from the variable, and that what's as far away as possible is this -4 out here. So I'm going to go ahead and add that to both sides, and that's where I'm going to start solving the equation. And that gets me to 24. And as I move back towards the variable, the second thing I get to is that set of absolute value bars on either side. So I need to deal with those green absolute value bars. And remember that we deal with absolute value bars by breaking ourselves into two paths. One, the path which keeps the expression inside the absolute value bars positive, and the other the path that keeps the expression inside, that takes the expression inside the absolute value bars and makes it negative. I now move forward, and the next thing that I get to is I get to this constant. In one case it's a 3 down the positive path and a -3 down the negative path, and I need to divide that away from my term, so x cubed equals 8, or x cubed equals -8. And finally, I'm going to go ahead and take care of that power. I'm going to take care of that power by raising both sides to 1/3. Remember, that's how I'm going to reverse that power in both cases. And the result now is I get, for one path, x equals 2, and for the other path, I get x equals -2. And there we go. We have two solutions. Two solutions by thinking about the order in which I'm going to unpack that set of operations. Now, we might want to know, for example, are there actually two solutions here, right? We've been talking about whether or not two solutions actually exist for equations, or is it one solution, or did we have to multiply through by an even root, or did we raise both sides to an odd root, right? So we have some decisions we made there. Right here, we should only expect one solution out of each path. Okay, the negative path produces one solution. And you can see that's because we raised to the 1/3 power. That's an odd root. So we no need for plus or minus. And that had been our rule of thumb. But we have two solutions ultimately for the equation because there's two paths that come out of the absolute value. Let's look at a second one. So here's the second equation. It's once again color-coded. Let's see if we can jump through this a little bit more quickly. This time to get as we get ourselves closer and closer to the variable, we're going to have to start on the outside of the equation. And I might rewrite the equation as absolute value of 3x minus 2 raised to the 1/2 power equals 2. Remember, the radical bar is the same as raising something to the 1/2 power. And before I can get at anything inside those absolute value bars, I've got to get rid of that 1/2 power. So I'm going to take both sides. I'm going to square them. So I have absolute value of 3x minus 2 equals 4. And we're in an absolute value again, so we know that, okay, I unpack an absolute value by taking a positive and a negative path. 3x minus 2 equals 4, or negative 3x minus 2 equals 4. And we continue to solve down each path. So 3x equals 6, or x equals 2. Or on this other path, I have negative 3x plus 2 equals 4, or minus 3x equals 2, or x equals minus 2/3. And the question we should ask ourselves at the end here is, are there actually two solutions? Remember, whenever we work with absolute values, sometimes we find ourselves with extraneous solutions because of our process. And if we want to do that, remember that our check for whether or not we have the right number of solutions is to think about what the graph of both sides of the equation looks like. Right? So if I'm thinking about the square root of absolute value 3x minus 2 equals 2, then I'm really thinking about y equals the square root of the absolute value of 3x minus 2. And I'm thinking about y equals 2, and I want to know where the intersections are. Now, I don't expect you to know how to graph that. We haven't talked about it yet. We probably won't. The collection of multiple parent functions into one is not something we have access to at the moment. But we can use a graphing utility to show us the graph and recognize that, in fact, there are two solutions here. Here's your graphing utility that shows you both sides. This is y equals the absolute value, y equals the square root of the absolute value of 3x minus 2, with our other line being y equals 2. And you can see two solutions here, one that seems to be at x equals 2, and one that looks an awful lot like it falls at x equals minus 2/3, which is what we got out from the algebraic process. So as you go through the more complicated problems, you really have to think about order. It's about order and unpacking the operations in the right order to get to the solution for the problem.